what we are looking at in 7.2 is really the power of radicals. For those, almost all of you are going on, you're going to run into this. And it's the idea of a definition of a base with a fractional exponent. It says, let A be any real number, let n be an integer greater than 1. If I'm looking at the square root or the nth root of A, then A to the 1 over n is equal to the nth root of A. What they're saying is this: the numerator of that fraction is the power on the radicand. A has a power of 1. The index is the denominator. Anytime you have a fractional exponent, it is a radical. Anytime you have a fractional exponent, it is a radical. And the reason why they do that is it makes radicals a lot easier to work with as you move into higher level mathematics, whether you're talking about college algebra or whether you're talking about calculus and above. Fractional exponents, why they're numbers. You can add numbers, you can subtract numbers, you can multiply numbers, you can divide numbers. Radicals are much more difficult to work with because now you're manipulating, excuse me, you're manipulating a symbol. It says convert the expression to radical form. Now what you notice is I have a set of parentheses. I do not care what's in the parentheses, by the way. That would be your radicand. The numerator is the power. The denominator is the index. So what you have is, this is negative 32, or that's the parenthesis to the 1 power. And the index is 5. So I'm taking the fifth root of negative 32. Fifth root of negative 32 is negative 2. Don't forget you got your power tables. You might find that helpful too as we're moving through. Here is 25 to the 1/2. The denominator is the index. So I'm talking about, since I have a denominator, the square root of 25 to the 1 power. Well, that's just square root of 25. What's the square root of 25? This is, whoops, white tape, I'm going to have to, I jumped ahead of myself. I didn't see the negative there. This is 1 over that set of parentheses to the 1/3 power. That set of parentheses is negative 64. Well, that means it's 1 over, the denominator is 3, so the index is 3, so it's a cube root. The set of parentheses is negative 64 to the 1, which is 1 over, what's the cube root of negative 64?
4.
Not negative 64. Negative 4, yeah. So I don't care what's in the parentheses. I move parentheses intact. It's like picking up a box and moving it from one place to another. Once you get there, you open the box and see what's inside.
So did the negative exponent make it?
Moved it down to the denominator. That's that old furry unfriend of ours that we don't like so much, that says property of exponents that a to the minus n is 1 over a to the n. That's that property of exponents. The one we don't like so much. Well, we don't like negative things, so. Now, denominator is 5, so this is the fifth root of x to the 1. Sometimes we move back and forth between radicals and fractional exponents. By the way, most of the time we're going the other direction. We are taking it from radical form to fractional exponent form because it's much easier to work with as a number. Now this is the thing that's going to drive you nuts. But this says, suppose what I have is a to the m divided by n. Now, as I look at it, and as I first defined it, we said, well, oh, okay, this is the nth root of a to the power of m. But to work with that is a pain in the rear. So what we do is this. M divided by n can be written in one of two ways. 1 over n times m over 1. Or m over 1 times 1 over n. This says root, then power. This says power, then root. This is what we like most often. And well, why is that? We've got a property of exponents that says that a to the m to the n power is a to the m times n. Well, you multiply the exponents. Well, multiplication can be written in either order. Multiplication can be written in either order. So essentially, if I take a to the m over n, this says root it first, then power it. Make the number smaller, then make the number bigger. Right? This says, well, I'm going to power it first, make the number bigger, and then try to take the root of that big number. This is the guy you're going to be more interested in. Make it smaller, then raise that to the power. So, for example, if I'm looking at 9 to the 3/2 power, that says the square root of 9 cubed. Square root of 9 is 3, and then 3 cubed is 27. Now, if I went the other direction, the square root of 9 cubed, how much fun would that be? I take the cube of 9, right? I can take the square of 9, it's 81, but then I'm going to have to take 81 times 9, and that becomes difficult. And then I'm going to have to take the square root of it. So it's easier to root it first, then power it. Now, notice that this is the same as -1 times 81 to the 3/4. Why would I say that? What's different about that? As opposed to what we did up here with the -64. What's the difference between -64 and this 81?
That's not raised to negative.
Yeah, this is not in parentheses, is it? 64 is in parentheses, so whatever happens to it is that exponent's on the outside. So that says what the only thing being affected by the exponent is the 81. You're going to do it first, and then you're going to take the opposite of it. So it's -1 times 81. Now, if I wanted the -81 included, I'd have to write it this way. That includes the -81. So this says take -1, and then I'm going to 4th root 81, and then cube it. The 4th root of 81 is 3, and then 3 cubed, and I can see I need more space, don't I? I need to move this guy over. Make a note to self. Do that in the next iteration of the packet. This then becomes a negative, what's 3 cubed? 27. So the answer is -27. I need more space between them. Negative 27, notice he's in parentheses. So whatever happens, I'm going to be looking at the cube root of that set of parentheses squared. Because I don't care what's in that set of parentheses. I'm operating on that set of parentheses. So it happens to be negative 27. What's the cube root of negative 27?
3.
Negative 27.
3.
Negative 27.
Negative.
Negative 3. And then I'm squaring negative 3, which is
9.
Here we go. Convert the expression to radical notation. Assume all variables represent positive real numbers. That means you don't need absolute values. There's strange little absolute value things. What is the square root of x to the 8th? Well, let's take a look. This is the radicand, whatever it is, right? It's x to the 8 divided by 2 power, right? The exponent is 8. The index is 2. 8 divided by 2 is 4. This is x to the 2 divided by 8, which is x to the 1/4, and I don't know why I put an equal sign there. I just got myself into trouble. To the 1/4. Now I can put my equal sign in. That is the same as what?
4 square root of 8x.
The 4th root of x to the,
First power.
yeah, denominator is the index, the numerator is the power. Now the exponent on 4 is 1, so this is 4 to the 1/4 power. Now we can get a little hinky on this. I'm going to choose not to. But what this is something that I want to kind of point out to you that we're going to run into is this. Notice that essentially I took the index, I divided it into the power. Index divide into the power. Index divide into the power, and simplify. By the way, when I'm talking about hinky, what is 4? 4 is 2 squared, right? To the 1/4. Property of exponent says this is 2 to the 2/4, which is 2 to what power? What's 2/4? 1/2, which is the same as the square root of. That's what I mean about getting hinky. It's like, Question is, do we care?